This is lesson 4.5, complex solutions. Last unit we looked at, our last lesson we looked at complex numbers, because when we solve quadratic equations, we often get complex solutions. So that's the goal. I can solve quadratics with complex solutions. So we're just going to jump right into this, and we're going to try and factor that. But what can you multiply to get 53? Exactly, 1 and 53, and that's about it, right? So this doesn't factor. I could complete the square if I wanted. This is a negative 14. I could just divide that by 2 and square that and add it to both sides. And so, but let's just go ahead and use the QF on it. Okay, that's probably what most of you are going to do anyway. So let me show you the completing the square. You might like this. So I'm going to move the 53 to the other side. Right, the constant goes to the other side. And then you're going to take half of the b, which is 7, squared is 49. And we're going to add 49 to both sides. Okay? So this becomes x minus 7, the quantity squared, and this becomes negative 4. So I square root both sides. And I get x minus 7 equals positive, negative, and then this is 2i because it's a negative 4. Square root of 4 is 2. Because it's negative, it gets the I. And so to solve, we simply add 7 to the other side, and we can't combine those because one is imaginary and one is real. And there's our solutions. Now, if we wanted to use the quadratic formula instead, we've got the opposite of a is 1 here. There's our b, and there's our c. So we'd have opposite of negative 14 is 14, plus or minus the square root of 14. 196, I think, is 14 squared. And 4 times a is 1, and c is 53, and all over 2 times a, which is 1. So in the radical, I have a 196 minus, and I got 4 times 53, which is 212. So I got 196 minus 212, which is negative 16. So I have 14 plus or minus the square root of negative 16 over 2. Well, that's 14 plus or minus the square root of 16 is 4. And with the negative, it makes it an I. And then I just divide each of these by 2, and I get 7 plus or minus 2i. So either one, whichever way you choose to do it. Now, the nice thing is, on this quadratic, the a value was 1, which made it easy to complete the square. Completing the square would be more complicated if it wasn't a 1, right? Like this one's a 9. Okay, so on this one, I'm definitely going to QF this thing, all right? So they asked me to write the answer in a plus bi form, okay? So that just means a real number and then an imaginary number. So here's our a value, our b value, our c value. So we're going to go with the opposite of b, which is positive 12, plus or minus 12 gets squared, which is 144, minus 4 times a times c over 2 times a. And so we've got 144, that stays a minus, and 4 times 5 is 20, times 9 is 180. So we got a 180 minus 144, or 36, so that's nice. Negative 36 over 18. And so that's 12 plus or minus 6i over 18. And what are all these values divisible by? Well, they're all divisible by 6, so this becomes 2 plus I over 3. But it says a plus bi form, so we're not quite there yet. We're going to write 2/3 plus minus 1/3 I. That's a plus bi form, okay? All right, give this one a try. Come back and see if you got it right. So we had to move the 4x to the left, put it in standard form. There's a, there's b, there's c. We're going to go with the quadratic formula on this. So the opposite of negative 4 is 4, plus or minus. 4 squared is 16, minus 4 times a times c over 2 times a. And this becomes 16 minus 48. Well, that's negative 32. So we got a 4 plus or minus the square root of negative 32 over 8. I got to break 32 out. 4 times 8 is 32. 2 times 2. 2 times 4. 2 times 2. It's a bunch of 2's. There's a pair of 2's, there's a pair of 2's, and there's this lone 2 that's left over right there. So we got 2 times 2 is 4, and then a root 2. So this is 4 plus or minus 4, because it was negative 32, it's I root 2 over 8. And then notice the 4, and the 8 all outside the square root. I can divide all those by 4. That gives me 1 plus or minus I root 2 over 2, which in a plus bi form is 1/2 plus or minus root 2 over 2i. Okay. You'll find an assignment in Delta Math 4.5, Complex Solutions.